Just go, I'm doing it in Desmos just so you can kind of see what's happening here. Let me grab this and then, okay, so graphically what this means when you're finding the integral is the area under the curve
Okay.
to the x-axis. So it's from 0 to pi, 0 to pi, and you just sort of connect it. And what you're doing here is you're just finding this area under the curve there. Okay.
Right.
So there's a simple like rule here, which is if the area is above, I guess I'll write it this way, above it means it's positive. If the area is below, that means it's negative. Right. So if you look at the instructions for this first problem, it just says, is the definite integral positive, negative, or 0?
Okay. Yeah, so this
Right.
this would not show up on a test then, something like that.
Probably not, but you could be asked a question. I mean, like you could, there's a ways to kind of make this show up on a test. But you have to know this part, whether the area is above or below, because sometimes it dips above and below in the same thing here. Let me see if this one does. I don't, this one does not. So let's see here, like number 7. Can I do number 7?
Yeah.
Okay. I think it'll maybe illustrate this point. If not, I'll draw something to do that. So really important that you bound this function properly, meaning like the window that it suggests here, where root x squared plus 1, and we're going from -2 to 2 this time. All right, so let me grab a snip of this. So you can see in the Desmos, you have to use these curly braces to bound the function. So let me keep it in here. So you can see, like, because it's going from -2 to 2, the integral, you bound the function like that.
Yeah.
And then so this part, there's a part up here which is positive, and there's a part down here which is negative. Okay. Now these end up canceling because this is positive, this is negative, it's the same area above and below. So the integral is actually equal to 0 here. And it has to do with the fact that this is an even function. I'm sorry, not even function, an odd function, which may come up again and again. This idea of even and odd functions, I'm not sure if that was mentioned in the notes, things like that. So like where this is going, and I guess let me just draw a more generic thing here. So let's say the curve looks like this. And this is, we'll go from 1, 2, 3, 4, 5, 6, 7, 8. I didn't draw that very well. Let me draw this better. Something that, let's say it goes like there. Like that. Okay. So 3, 4, 5, 6, 7, 8, 8. Okay. So this is, consider this f of x. So the integral f of x from 1 to 3 dx is this area here under the curve. And I don't know what it is, but do you agree that it's greater than 0? It's positive.
Yeah.
And so the integral from 3 to 8 f of x dx is less than 0 because it's below the x-axis. And it's kind of like, if you remember, like long ago when you added and subtracted positive, negative numbers, like we don't know what this number is, but which one like is more, like this one's positive, this one's negative, but which one's like more in that direction?
The 1 to 3.
Okay, sorry, so I'm not asking it well. Like if you just could look at the areas without the sign, which would be bigger?
Oh, 3 to 8.
3 to 8. So the total integral from 1 to 8 f of x dx is less than 0 because the one that's more, this one down here contributes more than this one up here.
Right.
Okay, and that's the whole point of like these first few exercises, although they kind of look like they're all um the same. Like
Okay,
like they're not giving you much variety on them. So if that's clear, we can move on to like 9 or
yeah,
10
that's
or
what I was thinking.
okay. Let's go to I need to do this differently. I'm going to do 10 and then have you do 9 to help you kind of because this is something you do need to do.
Okay.
And your calculator will do this for you, but you think you said you have to show some work when you're doing problems?
Right, yeah,
Okay,
yes,
so this is the first time you've seen these bounds really. And we're going to talk about what to. So you ignore them for the moment, and you just have to find the antiderivative or the integral of the things here. So like, what's the antiderivative of 7? Do you remember that from last week? Just a constant.
um,
So it's 7t,
oh,
7t.
right, okay, yeah,
So
yes,
the integral of a constant dx is the constant times x. How about this minus 3t? Do you remember that one? That's the power rule.
yeah, so then it becomes, 3 times the,
So the
1,
integral of x to the n dx. So when it's a is you add 1 to the exponent and divide by the new exponent.
right,
And if
okay,
there's a constant, it comes with it.
C, right? Plus
Yeah,
C?
well, okay, C's maybe a bad one. Let me say K, K here. The plus C is always there at the end,
Yeah,
but what I'm referring to here is just a number in front of the thing. So
oh,
here it's T 1 + 1 over 1 + 1.
okay,
All right, so now normally there's a plus C, right?
yes,
Okay. And in this case, there is not a plus C. Okay, so there's
okay,
two types of integrals that you're going to see here. There's indefinite. So that's the integral of some function dx, and it always has a plus C. What we're
right,
doing today are called definite integrals. Integral from a to b f of x dx, and there's no C. And I'll explain why in a moment here, what the mechanics are here in a moment.
okay,
Okay. So the so the let me clean this up. So it's 7t minus 3t squared over 2. Now this vertical line here is like taking the place of the C, and you put this -1 and 2. Okay, and what this means here is you're going to evaluate at the top minus evaluate at the bottom. Okay, so let me just grab this here. So a lot of explanation for the first one, but you put the 2 in for t, so it's 7 times 2 minus 3/2 2 squared minus, so all of this over here is the top, then you put it in the bottom, or you put the bottom number in for t. So it's 7 times -1 minus 3/2 times -1 squared, like that. Now it has to be in parentheses. It's top minus bottom. Is that
mhm,
okay?
yeah,
All right, so now we got to get these numbers. This is the hardest part, but you go right to your calculator to get that if you
right.
want. Okay. And you should, like, there's no reason to do this by hand. You just be good with your signs here. Do you want to give that a try for us, please?
Yeah. Oh, shoot. I got 33/2.
Okay. Very good. Now, if you scour the internet, you'll find a way to do this, like on your calculator, or actually you would start up here on your calculator, and I can help you find those links. But you need to show the antiderivative, then you need to show that you're evaluating at the endpoints, and then if you want to go to your calculator, that's fine. But just make sure you show your work here.
Okay.
Okay, so let's go back. Let's do let me do another one here. Let me do number 12, and then I'll have you do one on your own here. So number 12 here. The first thing you should notice is it's a definite integral. It's got bounds, a lower and an upper bound. And so you got to find the antiderivative of each of these, and it's the same one. X to the n dx always becomes x to the n plus 1 over n plus 1. You add 1 to the exponent, you divide by the new exponent. If there's a constant, the constant comes with, meaning that when I say constant, the coefficient, like a 6 in this case.
Yeah.
So the first one here is 6x to the 2 plus 1 over 2 plus 1 minus 3x to the 1 plus 1 over 1 plus 1. And there's no plus c because you're evaluating from the two endpoints. So this vertical line means you're evaluating. So you've got 6x cubed over 3 minus 3x squared over 2. I would recommend simplifying, coefficients, to make it clean up here. Okay, so again, it's top minus bottom. And I think you said you were not taking calculus 2, but if you were, that would be an important thing to remember. That's why I say it that way. So it's 2 times 2 cubed minus 3 halves times 2 squared minus big parentheses, because you have more than one term here. You don't want to miss the signs. That's why it goes in parentheses. 2 times 1 cubed minus 3 halves times 1 squared, like that. So go ahead and give that a try, and let me know what you come up with.
(19/2).
So this is not uncommon to get traditional answers. Really is not. You need to be comfortable with that. You might want to do the calculations a couple of times just to, trust yourself, that you've done it right. I can show you how to do it fully on the calculator, but you do want to be able to show it by hand. So let's go back to 9 here and give that a try on your own. And of course, if you have questions, please ask. I'm gonna go ahead and work it out on my side, and we'll
So it becomes 2x²/2, but then you just get x squared.
What about the -1? What's the antiderivative of that?
1.
The other way to think about it is like what function's derivative gives you -1?
Mm,
So remember, if it's the integral of a constant dx, it becomes the constant times x.
So it's
So
just one X. The,
so the integral of one dx, the constant is one. So it becomes one times x. Now you have a
okay.
negative in front, so you can either put it there or you can treat it as negative one dx, and then it becomes negative one times x. Up to
Okay.
you.
So negative X then.
Okay.
Oh,
So something like x squared, once you reduce minus x evaluated from -1 to 0.
yeah.
Okay, so give that a try, please.
-2.
The answer is -2. And that's possible. Like if you were to graph this, which you don't need to, but if you were to graph this, the line looks like this from -1 to 0, and you can see that all of that area is negative.
Yeah.
All right, let me have you try 11.
Okay.
Gotta have you try one more here, see if you can do it fully. Um, so give that a try, please.
-10.
Sorry about that. What is your antiderivative on this?
Uh, T to the third over 3 minus 5X.
5t, yeah. And you're
But yeah,
valuing from -1 to 1. Okay.
yeah.
So from here, they're probably just a calculator error. So it's 1 cubed over 3 minus 5 times 1 minus parentheses -1 cubed. Notice I'm substituting in parentheses, very important. Would you
Yeah.
mind trying that one more time? I think you'll get a different result if you do.
Yeah, I did it with the parentheses. I'm confused where I went wrong. Let me just retype it in.
I'll try it again on my side. I mean, I'm prone to making errors, especially lately.
Oh, -28 over 3?
Yes, that is what I've got.
Strange. I
So
don't know if I made a mistake.
now, if I'm the instructor, I'm putting in all the possible mistakes that a student can make. Like then your answer probably would be there. So it'd be good to do it multiple times and go with that. Okay. Let me look and see what else you have here so we can cover, everything that we need to. So just more of the same. Yeah, we should do a few more of these. Oh, this is kind of just, this is the worksheet practice. type thing. Okay. Yeah, so I'll do a few more here for you. Let's look at like 22 next, if that's okay. So 22, it's a lot like what we were doing last week, and then we were doing with derivatives where there's kind of a rewrite step first. So in this case, before you do any calculus, you want to distribute in 6 square root t minus t times square root t. And then if you remember, the square root of t is really t to the 1/2. And if you have, two bases that are the same, you add them. Right, so this becomes 6t to the 1/2 minus t to the 3/2, like that. Again, we've still not done any calculus. We're just
Right.
rewriting this thing. Is that okay so far? These are just rules from whenever you
Right.
learn them. So now you got to find the antiderivative. You got to add 1 to the exponent. You bring the constant down. You divide by the new exponent. Add 1 to the exponent. Divide by the new exponent, like that. 0 to 3. And if you're really a calculator whiz, really you got your calculator down. Like, you don't have to rewrite these. You can let it. You can just work with the fractions within the fraction. It's totally up to you. I proceed. Probably is worth doing some simplification, but I can't say for sure.
Yeah, it's just better to have most of the work on the page because if there is a step that goes wrong or something, sometimes he
Yeah.
gets like it. So
So again, so 4, and this is we're coming up on some problems where the calculator will not help you. So sometimes it does with these exponents, but you're going to see here, like this one does not, because 3 to the 3/2 power is really the square root of 3 cubed. And I'll show that in a moment. Point is you can have some issues. Now, zero to any power is 0. So everything on the right side actually goes away, which is nice. Yeah, that goes away and that goes away, like that.
right.
Okay. So now it's 4 times the square root of 3 cubed minus 2/5 the square root of 3 to the 5th. Now, this is not the final answer, and it's just manipulation of exponents, but you probably haven't done that in a while. So we'll just quickly review here how to do this. This middle one, the first one is really 3 squared times 3. So you can bring that 3 out from 3 squared. 4 times 3 square root of 3. Sorry, this is a square root, not a cube root. Is that clear? Or do you want me to?
No, that makes sense.
Okay. And then over here on the right, it's 3 squared times 3 squared times 3. Yeah, 2, 2, and 1 gets you to 5. And so from the 3 squared, a 3 comes out. From the 3 squared, a 3 comes out. So it's 2/5 times 3 times 3 square root of 3. 12 square root of 3, like that. Does that make sense?
Yeah.
So now you end up getting 18 over 5 square root of 3, 12 square root of 3. And so what do you do from it? Well, you got to combine the fractions because they're both root 3. So this is 60 over 5 root 3 minus 18 over 5 root 3. That becomes 42 over 5 root 3, like that. Now,
Yeah.
what you could have done at some point is you could have just gone to your calculator and said, okay, 12 minus 18 over 5, what is that? But you can't put the root 3s in because they're irrational. And your calculator doesn't like irrational numbers.
Right.
So this would be your final answer. And like if you went to the calculator and just did this original one, even just this line right here, you'd get some decimal. Then
Right.
you'd have to know that that was the same as this. And I don't know how you would know except to try them all.
Right. Um. Can we do 31?
Sure. Okay, so this is moving into a different part of, no, I take that back. This is not. So there, this is, there are three Pythagorean identities that you need to know from previous course here. Let me go and grab
Yeah,
those.
we did those last semester.
Yes, and thing is like, I would put them on a reference sheet.
Yeah, no, I agree.
But here's the three of them. So they're in the order that you need to remember the most by. So the first one is more important than the second and the third. 1 minus sine squared theta, you might be thinking, well, that's not there. It's sine squared theta plus cosine squared theta. Well, it's not. But if
Yeah.
you move the sine squared over, if you subtract sine squared theta from both sides,
Yeah,
you get cosine squared theta equals 1 minus sine squared theta. The numerator becomes cosine squared theta.
right.
So in this section, and the integrals do get more difficult. In this section, though, you're not doing any substitutions that are complicated. You're just doing things that you might already know. So cosine squared over cosine squared is 1. This becomes the integral from 0 to pi over 4 of just d theta, or 1 d theta if you want. What is the antiderivative of 1?
1x.
Or theta, and this just use that variable. So just,
Theta.
yeah, 1 theta or theta evaluated from 0 to pi over 4. Which is pi over 4 minus 0, which is pi over 4.
Okay.
Okay, so the idea here is like, that was a good one to pick because it's like, but 32 is the same way. 32 is another one. Some of them look like you can't do them, but then you realize you actually, there is something whose derivative is that, like, the derivative of tangent is secant squared. So like, these are all like lookup problems. Look up in your table, like a 33 here, for example. You might sing at first like, oh, I don't know how to do this, but uh, it's really the the derivative of tangent x is secant squared x. So you actually do know the antiderivative of this. Like, it's in that table of derivatives that I sent you.
Right.
So the more you kind of scour that list and look it over,
Yeah, I use that for my reference sheet this week. I use it on there.
great.
Let's see. Should I do 37?
Sure. Right. Yeah. So 37 here wants you to find the area under the curve. Now, normally you're just given the integral, but you need the lower and the upper bound. You can think of it as left to right. Okay. So in this case, it's the integral from 0 to 1. Do you see how I came up with those values here?
Yes.
Okay. Now, if this thing swung down, it would be a different story, but it doesn't. We don't have to worry about that right now. X minus x squared dx. I'm just grabbing that function. All right, so why don't you try taking the antiderivative here, evaluating the endpoints, and going from there.
Negative half.
Say that one more time.
Negative half, 1/2.
Negative 1/2. Okay, what is your antiderivative?
X squared over 2 minus x squared.
You have to take an
Oh.
antiderivative of both.
Oh, minus the third, sorry, over the third.
Okay, all right.
Yeah,
So this is not 1/2. So try it one more time. The bottom, when you put the bottom in, it does go to 0, so you only have to evaluate at the top, but that's only because it's a polynomial here.
one-sixth.
Okay, any other problems you'd like us to do today?
Can we do one of the ones from 47 to 51?
Sure. Oh yeah,
Um,
there are more here. I thought we were at the,
No, it's
the mean value theorem. Okay. Yeah, 48. So these look more complicated than they actually are. There's a formula for the mean value theorem, MBT for integrals. So it's like this. It's the integral from a to b, f of x dx, just like before, but you add in this 1 over b minus a. So that is it. So like in your problem here, a is 4, b is 9. Your f of x is the square root of x. So it's the integral 1 over 9 minus 4 square root of x dx from 4 to 9. There's nothing really more difficult, and graphically it has a really cool interpretation, but they're not emphasizing that here. But graphically, let's say that's 4 to 9 right there. It's this place where you cut the area, and it's the same on the top and the bottom. You have half on top and half on the bottom. It's got kind of a cool thing here. So in terms of actually how you do this, though, I mean, square root of x is really x to the 1/2. The antiderivative is x to the 3/2 over 3/2, evaluated from 4 to 9. But then you've got this coefficient in front, 1/5, like that. So it's 2/3. You got to bring this 3/2 up. So it's 2 over 15 x to the 3/2, evaluated from 4 to 9. So that becomes 2 over 15, 9 to the 3/2 power, minus 2 over 15, 4 to the 3/2 power. Now this one actually works out nicely. And there's a couple ways to do it. You could literally go to your calculator and type in 9 to the 3/2. You could also remember that 9 is 3 squared and 4 is 2 squared. Okay. And so this becomes 2 over 15, 3 squared to the 3/2, minus 2 over 15, 2 squared to the 3/2. And if you remember, when you have an exponent to an exponent, you multiply them. So when you take the 2 and multiply it by 3/2, it becomes 3 cubed. The 2 as the exponent here times 3/2 becomes 2 cubed. 2 over 15, 2 over 15 minus that. So it ends up being 27 times 2, which is 54 over 15, minus 8 times 2, 16 over 15. So it ends up being 38 over 15. And you get a lot of answers like this that don't really mean anything. Like 38 over 15, what is that? Well, that's why you should do the calculations twice. You could do them by hand and then go to your calculator and do it on the calculator that way. Things like that. So, We do have to stop here. I'm happy to add some time tomorrow if we need, or another day, if needed, but we're scheduled for the same time every day this